All right, I've got one more on buoyant forces. This is kind of just more of an idea of illustration, but I'm going to have three situations that I'm going to draw real quick. The first one is going to be kind of what I think is the easiest. So we have an object that is floating in a container. So what are the forces on this object? Well, we have Fg and we have Fb, right? And they're gonna and we have the gravitational force and the buoyant force, and they're equal because the object is floating. In another situation, I'm gonna have an object in water, but it's gonna be suspended up. So what are the forces on this acting on this object? Well, we have force gravity again. There is a buoyant force again, and there's also force tension pulling up. So in this situation, this object is more dense than the water because it's not floating. But so you need the sum of force tension plus force buoyancy to equal your force gravity. So with some rearranging, we get force tension equals force gravity minus force buoyancy. And then in a third and final situation, I'm going to have an object that is in water, but it's held down on the bottom. If you can see that. So once again, we're going to have force gravity pulling down. We're going to have a buoyant force pulling up. But this ball wants to go to the surface. It wants to float. So we have a rope tied to the bottom holding it down, and so we're going to have a downward force tension. So an equation for the sum of the forces here would look like force buoyancy equals my force gravity plus force tension. So once again, doing some rearranging, force tension is going to equal force gravity plus force buoyancy. So instead of memorizing this equals this thing is this thing, just think about the situation and understand what is going on when you look at the situation to figure it out.